Hi, my name is Aneta. In today's video, we're going to practice some past paper questions on enthalpy change. Okay, so the first question I've got here is write the enthalpy of combustion equations for the following reactions. The first one we've got with carbon. So during combustion, oxygen is added to 1 mole of a substance. And this is what we're going to do. So carbon as diamond, so we can write diamond in the brackets. And then we add oxygen. It always goes in pairs, so the little 2 is there. Carbon and oxygen, when added together during combustion, form carbon dioxide. Just going to write the state of carbon dioxide here and the state of oxygen here. And the equation is already balanced. 2 oxygens on this side, 2 oxygens on this side, and carbon on either side. The next example we've got is ethanol. So the first thing we've got to do is put the ethanol. As with the previous example, we add oxygen during combustion to form carbon dioxide. As you can see, we also got hydrogen present. So during combustion, when oxygen is added, water is produced as well as a steam. We can clearly see the equation is not balanced. If you don't know how to balance equations, please visit my blog. I will leave the link down below with balancing equations and then come back to this video. But if you know it already, then just carry on with me. Got 2 carbons on this side, 1 carbon on this side. So we're going to put 2 in front of carbon there. So we've got 2 hydrogens on this side and 6 hydrogens on this side. So we're going to put 3 there. So we've got 6 hydrogen on either side now. Now we're just going to count the oxygens and see how many more we need on the left-hand side. You already got 3 here, but on this side we've got 3 plus another 4. So if we put 3 here, we've got 7 oxygens altogether. And if we just count these, it's 3 plus 4, which is 7 as well. Okay, so here we go, another question. Write the enthalpy of formation equations for the following reactions. The first one is with cyclohexene. So in formation equations, you just want to put the product on the right hand side and then see what it's been formed from. So as you can see, there is carbon and hydrogen, so it's been formed from carbon plus hydrogen. Hydrogen always goes in pairs. And then we just gotta balance the equation again. So we've got 6 carbons on this side, so we put the big 6 on this side, so 6 either side. Then we've got 12 hydrogens on this side, but only 2 on this side. So if we put 6 here, we've got 12 on each side. The next example is with methanol. We also put it on the right hand side. And now we just gotta look for what's in the methanol that we have to put on the left hand side. I hope that makes sense. So as you can see, we've got carbons, hydrogens and oxygens. So we can put carbon, hydrogen and oxygen can be combined to form water. And this is the easiest way to get methanol. Hydrogen with oxygen, water, plus carbon. And they are already balanced. In these type of questions, you just gotta put the product down and then think through what elements can make up that product. Okay, so here we go, another question. We've got the equations shown there, and then the question says, using the standard enthalpy change for the reaction above and the standard enthalpy change of formation given in the table below, calculate the standard enthalpy change of formation of gases gaseous ethanol. So the first thing we know is that enthalpy change of reaction is equal to the change of standard enthalpy of formation of product minus standard enthalpy change of reactants of formation. So, bearing in mind this, we know that the enthalpy change of reaction is minus 46. So I'm just going to put all the information I already know into the equation. We don't know the standard enthalpy change of formation of the product, which is this ethanol. That's what we have to find. So I'm just going to put a question mark here. And then we take away the standard enthalpy change of formation of the reactants, which is hydrogen with oxygen water and ethene. So we're going to take away 52.3 plus minus 242. So it's minus 46 equals question mark minus this all combined together, which is 189. But we also got to put the minus here. What we're going to do next is just these two minuses together are a plus, because minus and a minus is a plus. So the question mark will equals minus 46. It's a plus on this side, so when we take it over, it's a minus 189.7, and that will equal our question mark. Minus 46 minus 189.7 is minus 235.7 kilojoules mole minus 1. This is the unit for standard enthalpy change. And we're done.